Hi, my name is PJ McTavish and welcome back to another D.C.G tutorial. This question is from 2013 paper. It's ordinary level question and it's question C-5 Assemblies. So as always, let's read through it and see what it's asking us to do and then figure it out from that. So details of a clamp mechanism from the top of a bicycle stand as shown on the right are given in figure C5 below. A 3D graphic of the individual parts is also shown as well as tabulated parts list. Draw the sectional elevation AA of the assembled clamp mechanism. All chamfers are 2 mm by 2 mm. Any omitted dimensions are may be estimated. So they're giving you a 3D graphic on the right showing a bicycle stand, and this is like a V clamp at the top that clamps down and keeps the bicycle in place. We have 5 parts and you get a 3D at the bottom of what it looks like as well as a parts list. And the parts list is very important. So part 1 is the bottom clamp jaw, part 2 is the top clamp jaw, 3 is your clamp and screw, and 4 is your M8 bolt, and M8 hex nut is part number 5. Now, the names are very important because part 1 is your bottom jaw and part 2 is your top jaw. So, from laying out on the page point of view, you'd want part 1 down low and part 2 obviously above it. Okay, this assemblies question is different from the last assemblies question we did because it's asking for sectional elevation, and if you look at the plan of part 2, what you're going to do is cut off the front half and show the back half of it all assembled. So basically what we'll see is a cut right down through the center. So to start that, I'd start off normally with the elevation of the part that has a sectional view on it, in this case part 2. So we can start off with part 2 and that way we can work down. So part 2 is the top jaw. So part 2, you need to have it up a bit further on the page so that you leave room below for part number 1. Okay, so let's do our top lines up. Right, our measurements are, we have an 8mm and then we have 132. Let's mark that in first. So we have 8mm. Let's see if there's any scale on this. Scale is 1:1, so there's no scale. So we have 8mm and then we have 132. Okay, 8mm is just for the thickness at the top there of that V, and 132 is giving you the center over here for the 90-degree bend down, and it is diameter, or the size of it is 8mm. So if I go, well, I'll do the V here first maybe. So it is 45 degrees. So let's go 45 degrees from the H to the left and 45 degrees to the right hand side. From the top there then we have a few more heights. We have 16mm down, so let's go down 16mm. Get the top part here. So our 45, let's see how far down it goes. It goes down 6mm from the bottom. So this is the top of the bar. The thickness of it is 8mm, and then 6mm down from that is the bottom of the V. So measure down 8mm. Draw that across slightly. And then measure down 6mm. And you have the bottom of the V. Okay, so that's the bottom of the V there. The thickness of that then is 12. So we have a 12mm thickness here. And it is just that 12mm doesn't look right. 12mm. That's why this is 12mm here. 12mm thickness, and you want the center, or the center line there. We'll measure half that, 8. 1mm. We can go 45 degrees down the far side. Okay, so that's that V done on that right hand side. We have the thickness going across here. Let's do the left hand side first before we mess around with that hole there. So the left hand side then is this 32. So we're going to go 4 mil either side of that to figure out how far over it goes. This is 4 mil and this is 4 mil here. Draw them down. You can extend over your 8 to the top there. And the distance down from the top of it is 24 mil to the center of that circle. So 24 mil. That is the center of a circle here now. And the diameter of it is, we have two circles actually. We have concentric circles. We have diameter 24 and diameter 8. So let's put in our diameter 24 first. That would be radius 12. On that center line there, center point here. And then our diameter 8, which is the size of this bar here. So we have a radius 4 mil hole there as well. Okay, so we're just going to zoom in. So there is our V, we have our thickness coming across, and we have our circle here. Last thing to put in now is we'll have that hole and lip at the top. So you're cutting it down the center. So if you're cutting it down the center, there is two strong lines over here showing the angle. You're not going to see them, okay, because they're at the back now, so they're not going to be put in. What is going to be put in though is the hole right down through it and also the lip at the top. So we're coming over 36 mil from the edge of this V. Okay, 36 mil. So I just bring that over straight to make sure that the measurement is right. So 36 mil, and that is giving you the center of that hole. So put in the center line. That's the center of that hole there, and the lip of it at the top is diameter 28, and the size then of the hole itself is 16. So the size of the hole is the length of it is 16. So if we go 8 either side, it give us our 16. Also, the lip at the top is 28. So if we go 14 either side, we get the size of the lip. So this is the hole going down through there, the hole going down through there, and the lip up. Height of the lip is 4 mil. Let's measure up 4 mil. Now that's a lot of part 2 put in. So we'll have our size, our circle down here. We have our bar going up and the hole through the center. Now if it's cut right down through the middle, that hole going strong. Same as the lip. Okay, it's all going to be one part, and the same with the V. Okay, now we might just mark in the points that we're going to see before we move on. Okay, so that's pretty much all of part 2. And part 2 was the top clamp. So let's put in the bottom clamp, which is part 1. Look at the elevation of part 1. You have the same diameter 8 hole over on the left of it. You have that same V shape over here. So you need reference points. You need to know where they're going to attach together. Now I could start with the V, touching off this V here and working down. But I'm not too sure if that is going to be touching. We don't know if the clamp is open or closed. What we do know is the diameter 8 hole here on part 2 needs to line up with the diameter 8 hole of part 1. So we're going to work off that. This is going to be our datum point here, off that center. Alright? So from here, put in your measurements. I'm going to bring that center line over. I'm going to use my measurements then from there. First lengths I have is 66, 36, 12 and 22. Let's put those in. So we have 66 is over to the center of the hole, and that's actually, we have that center here, that's that 66 line there. Then we have 36, we should have that as well. Yeah, that's lining up. And then 12 and so on. So they actually are lining up there. And the thickness of it is 8mm, just like the original part number 2. So measure down 4mm and up 4mm. That'll be the thickness of the bar going across. The V's then, they are touching off each other here. Okay, because I said it was up 6mm, and let's have a look if that is 6mm. It is on the dot. So we can actually draw in our V for the bottom clamp off the V from the top clamp. We can also bring down the center line. Extend down that center line. That's where it meets there. We can bring down the size 8 either side we have here, and that will show you where the straight line is at the bottom there. Okay, the clamp is cut off there, it's not going to the V shape that we had. Next, what we need to put in is the holes, and in this case it is not a size 16 hole or so on, it's actually different. The lip is 36 and the center hole is M10. So if that's M10, then you draw diameter 10, and it's on the same center line here. So M10, we need to go 5mm either side, 5mm, 5mm. Draw that down through it, and the lip is up 6mm and it's diameter 36. So if it's diameter 36, we need to mark 18mm either side. Draw that up. And sorry, the height was, what was the height? The height was 6mm. So we need to measure up 6mm, and actually that was our 6mm here, so it's actually in line with this. And that is the little lip. So I'm going to put that in. See, now we might be able to zoom in a bit further. I'm going to mark in the points of that part number 1 in blue, just so they stand out. So the assemblies, we'd rather draw it in strong at the end when we know exactly where everything is going. Now the section view is cutting everything in half, so we need to look at the drawing to see how everything's fitting together. Okay, so let's focus on the end here for a second. Part number 2, if you look at the plan, part 2 narrows, and the circle part here, the circle part is only 20mm wide. If you look at part 1, it is actually cut in half there, and you have 2 bits either side, and there is a gap left in between. So this circle here is going to be visible and it's going to be strong for part number 2. So that means our part number 1 here is going at the back, so you won't see that. Alright, so that's parts 1 and 2 done. Next important part, I would say, would be part number 3. So if you look at the parts list, part 3 is a clamping screw. So clamping screw is going to clamp everything together, and it has an M10 thread at the bottom of it. So the M10 thread is going to fit into the M10 thread down here at the bottom of part number 1. Okay, and to put in the thread as well, we need to measure in 1mm to show this thread there. We'll do that at the end when we're drawing in strong. Alright, so that's M10, and it is diameter 36. There's a 10mm gap. So I draw that in sitting right on the top here of part number 2. Okay, so it's going to be resting on there, it's going to sit down through the slot. So we have our center line here. Okay, so let's work out that center line to mark in the clamping screw. Okay. So that's our center line, and it is diameter 36. So again, go 18 either side. Let's extend this out. Diameter 36, actually this was diameter 36, so we can just bring that bring that up. The height of it is 10 mil. And it said any chamfer that was omitted was, or all the chamfers were 2 by 2. So that means we need to measure in 2 mil from the edges. And put them in at 45 degrees. Okay. Now it is M10 and diameter 10, so that means this diameter 10 hole here, draw that all the way up to the base of it, and that will give you the size of the pin. Alright. Next thing we have measurement, so it goes down 16 and then the tread starts at 16. So it goes down 16 mil. Down 16 mil here, and then the tread starts from that point down, and then it goes down 16 from there. So let's measure down 16 mil, find where it ends. That's 10, 15, so 16 mil there. So it's stopping just inside here. Alright, so that is the shaft of it coming down here. The tread starts at that 16 line here, and it stops there. Now in assemblies, if you're showing a sectional cut, everything has to be cut along a certain line. In this case it's cut right in half. But screws and bolts and pins and other elements like that do not get hatched, like ribs and so on. So in this case our clamping screw and our shaft and the M10 down here, that's not going to be cut, so we can put that in strong. Okay, so just a bit of shading on that so it stands out from the rest. Now, you had two more parts to do. You had part 4 and part 5. So part 4 is your M8 bolt and part 5 is your hex nut. So M8 means that it would be diameter 8 shaft and it's fitting through here. There's no hidden detail in assemblies, especially section view, so you could say that the nut was in the front and the head of the screw is at the back there. Either way, it's all going to be cut, and that it's fitting in here, it's going to be cut there. So there's nothing else to put in there. So we can draw everything in strong, and then after that I'll go through the hatching. Now, that is your parts all drawn in strong now. Remember we said that the top clamping jaw here was going to sit in the middle of the bottom one, so therefore this is in strong and the bottom one isn't. The little bit here is drawn in strong because if it's a hole is cut down through the center, you'll actually see the back of the hole, so you need to put that in strong as well. Okay, and again it's all one part, so therefore you won't have a strong line here. Next thing to do is the hatching. Okay, and hatching shows that something's been cut. And hatching is basically 45-degree lines that are equally spaced. Now, for these videos, I'll always do a line at the bottom here that has equally marked 10mm segments. But you don't have to be that accurate. It'll save you a bit of time in the exam just to draw your lines and try and keep them as equally spaced as possible on your sheet. Okay, so I'm going to put in the hatching for the top clamping. So if two parts are meeting, like we have here between part 1 and part 2, the angle stays the same, 45 degrees, but it changes. So from going down 45 degrees like this, we switch it around and we'll go 45 degrees in the opposite direction. And what that does is it saves on confusion between which part is which. Okay, so 45 degrees now, hatch in. Now, in the market scheme, if you look at the market scheme, it has hatched the bolt inside here, but you don't hatch bolts or nuts. So, in my opinion, I wouldn't hatch that. Okay, and that is the question done. So we have all the parts assembled, and you have a sectional view. So again, look, the hatch in here is just for areas that were cut. The hole at the back, you can see the back of the hole because it is behind the cut. Therefore, that's in strong, and there's no need to hatch it. So that's the question done. I hope that helped. If it did, please leave a like, and don't forget to subscribe to see more DCG videos. Okay, thank you and good luck.